afternoon, everybody. Welcome and thank you for joining in for another virtual tour of outer space. My name is Josh. I get to be your pilot today for our brief jaunt across our solar system and beyond. But the captain today, the person who decides where we're going, is you. You get to tell us where you think would be an awesome place for us to visit. If you know something about an object and you want to show off your knowledge, throw something in the chat. I would love to share the facts you know, and let us know where you're tuning in from. It's always cool to see where our audience shows up from across the Bay Area, across the globe. If you've got a spot you want to visit, again, throw it in the chat. We would love to see it. And today we'll be showing you all these really cool places in our solar system and beyond from our software called OpenSpace. OpenSpace is a product made by the American Museum of Natural History and NASA. We are proud to be collaborators with them, but it's a planetarium software that lets us fly to a scientifically accurate data-based visualization of pretty much the entire universe. And the coolest part about this is, unlike a lot of planetarium software, it doesn't cost thousands and thousands and thousands of dollars. The price is zero, free. You can download it at home and do pretty much the exact same tour I'm about to give from your home computer. So give it a shot. At the end of the show, if there's an opportunity for you, we would love to hear what you think of the software, what you think of the presentation. There will be a brief survey, and the first 30 people to fill it out get their very own NASA meatball sticker, which, as a big fan of NASA, as a big fan of stickers, is an awesome thing to do. So we are starting our tour of outer space at a place that is kind of synonymous with outer space for a lot of folks. This is Jupiter. Now, why would I start with Jupiter? Well, if you are a fan of Jupiter, you can actually see this planet in the night sky. We have a great opportunity to see Jupiter and Saturn right when the sun go down. They are very bright objects. Why is that? Well, they are big objects, number one, and number two, their surfaces are fairly reflective. Check out that beautiful smooth surface of Jupiter and all of those bands. Now, the bands and zones alternate between light and dark, all across the surface of Jupiter, and they give us a beautiful thing to check out. You can actually see Jupiter with your naked eye. It's a bright object. You will be able to spot it. And if you point binoculars or a telescope towards Jupiter, you can see some really cool detail. Perhaps the easiest starting point for a brand new Jupiter observer would be its biggest moons. So you can actually see those 4 moons called the Galilean moons traveling around it. You can see 1, 2, 3, and 4. Io, Europa, Ganymede, and Callisto in terms of order of distance out from Jupiter. Sometimes people who are just beginning to look at Jupiter think that they go in order Io, Europa, Ganymede, Callisto, but that's not correct. That's left to right distance or right to left distance. Don't fall for that trap. You might have to look online, but there's a lot of cool ways to do it to see which moons will be positioned where, and all you have to do is see the one closest to Jupiter is Io, second out Europa, third Ganymede, and then Callisto is fourth. On a good night, when things line up just right, you should be able to see that as a razor-thin line, basically extending out from Jupiter's equator. All of those moons hang out almost like a little tiny solar system. We've actually seen solar systems about the same size as Jupiter. If you think about the TRAPPIST-1 system, a very famous set of extrasolar planets that was found by the TRAPPIST instrument originally, and a big assist from our friends at Spitzer. Now, let's see. I think we had an early suggestion for an object to check out. Sam suggests the moon. Now, arguably, I could say I'm showing you moons already because we're checking out all these Galilean moons, but they have cool names. Our moon, the coolest moon for us here on planet Earth, the one we get to see the most detail on, is called the moon. I think that is the lamest of all possible names, and I am a big fan of people trying to come up with something a little bit more interesting. I like calling it Luna, so we could say we're heading to Luna right now. But then we get Terra, Earth, and Luna. It basically just means moon and Earth in Latin. So even that name's not that exciting, but it's a little cooler than just calling it moon in your own language. So if you've got a suggestion for what we should be calling the moon, I am open to them. Please let me know. Looking down on the moon, though, we get to see that beautiful bumpy and cratered surface. And actually, using OpenSpace, I'm going to show you what is the most prodigious set of mountains on the moon. It's this ridge right up here. I think these are the Apennine. But I'm going to try and fly right down onto it and give us a mountain survey from the lunar surface. Okay, so let's let that data tile in. It's going to get higher and higher resolution as we keep going. But looking down at the surface of the moon, check out all those bumps. There's some really cool stuff happening right there across the edge of the moon. Now, this is kind of a cool mountain feature and very different than what we have here on Earth because it actually curves. A lot of our mountain systems tend to be fairly straight. Think of like the Andes. Here on the moon, they are formed by a completely different process. A lot of the mountain structures on the moon are the edges of giant craters. Look around here. Notice how you've got that roundish structure? You could call this one gigantic basin. You can also see a lot of these edges of craters are actually raised significantly above the surface around them due to the way the crater is formed when the object struck the moon a long time ago. Now, we spent a little bit of time flying around the moon seeing some really cool stuff with Pascal Lee last week for our Cosmic Conversations. If you want to check it out, by all means, tune into our recordings. You can pull that one up and see all the cool stuff that Pascal showed us about where human beings might spend time on the moon. Now, we can also see some interesting evidence of lunar features in these dark patches. Way out here, you can see these dark crust structures are actually where lava flowed out across the surface a long time ago. Now, those lava features are today much darker than the area around them, and some people use that to see a shape in the face of the moon. Some people tell stories of the person on the moon called man on the moon, the woman in the moon, or a fox on the moon, or a crab on the moon, or a frog on the moon. There's a lot of stuff you can see, but we're seeing sort of a forced perspective because no human being really gets much of a chance to see the moon like this these days. Why is this a special angle? Well, it's because most human beings, in fact, right now, all human beings are stuck right at about this angle, because that's the angle the moon has with respect to Earth. So zooming back, we should end up relatively close to where Earth is in our solar system. I usually miss by a little bit. I did that time too. But if you wanted to see pretty much exactly what the moon would look like tonight, all I have to do is get us lined up, fly right through Earth. That happens sometimes. And right there, you can see about what phase the moon would be in. It's a little bit past our quarter moon. It's coming up on full. It should be full right around a month before Halloween, and then right around on Halloween. That's pretty cool. Sam's calling me to task. Do we have any asteroids or Callisto loaded? I will confess, I don't think we do. Why are Jupiter's moons in the same place and not more staggered? Great question, Richard. When we look at a lot of the more complex moon systems out here in the universe, we can see that the moons don't hold to a plane. Now, that's partially because we see a lot of captured objects, objects that were flying through space like an asteroid or a comet, flew a little too close to the object they were orbiting, and they got snatched. However, when we see a very flat level plane like we saw for the moons of Jupiter, or in fact for our own solar system, we can actually see that, well, a lot of these objects have that very flat plane, we think, because they formed around the object that they're orbiting. So let's check this out. Here we have our solar system. You can see the 4 planets closest to the sun: Mercury, Venus, Earth, and Mars. And then out here, Jupiter, Saturn, Uranus, Neptune. So let's check this out. When we are looking at the lined up objects right there, you can see that, well, it is not quite a perfect plane. It's really close. It's not exactly perfect because we've got weird kids like Venus rises a little higher and lower. We've got Mars has kind of an elliptical orbit as well. Mercury especially does. But when you add in objects like Pluto, you can see that, well, they have a really eccentric orbit, both in terms of the shape and how far above and below the plane they travel. So this is a system that is almost perfectly flat, but not quite. We can also say with a very high degree of confidence that our planets formed around the sun. That's a pretty easy question in astronomy. Now, when we start looking at a more complex system, let me see if I can take us to Jupiter and pull in some of those smaller moons. I don't think so, but maybe on Saturn, actually. Ooh, Corey's helping me out. The next full moon is tomorrow and on Halloween, which is lovely. I remember that we had a full moon on Halloween. Some people have been making a very big deal of that, which is pretty cool. But, okay, let's see. Do we have any There we go. So here on Saturn, you can actually see, let me take off our planet orbits. Hide planets, okay. Now, looking at these, see if you can put what I just said into action. Some of these moons probably formed around Saturn. They're the ones that hang out exactly there on the plane. If I had to guess one that maybe didn't form around Saturn, that was maybe a captured object, it would be this outer one right here. It still has a pretty circular orbit, with Saturn right there at the center. No orbit is a perfect circle, at least not usually. They're all ellipses. But when you start talking about this, it is a very close to a perfect circle. So it might have formed in place around it as well. It might just have a little bit of a tilted orbit. Ooh, I saw a question from Aaron. I can fulfill one of those immediately. You wanted to see Saturn's rings. Boom, right there. This is the angle where we are most aligned with Saturn's rings, but also the angle in which they are hardest to see. But you do get to see Saturn's rings casting a shadow on the surface of Saturn, which is what astronomers call super cool. And then the angle with which we see the rings best is maybe a polar view. Looking down on those rings, you can see part of them are obscured again by that shadow of Saturn. But then we can line up here and see a really cool view of the rings, where the sun is directly behind Saturn. And when that happens, you can see those rings illuminated in a very famous shot from the Cassini mission. They were able to send back a photo as Cassini flew past, and you can actually see Earth in the backdrop. It is a beautiful shot, and if you are a fan of space photography and you haven't seen it, go check it out. Now, we wanted to see Enceladus. I think we can manage that. Enceladus is one of the ice moons that I have up and running because people always want to see Enceladus, because Enceladus is kind of the teacher's pet right now. I shouldn't say that. I'm not as big a fan of Enceladus as I am Europa, but Enceladus is super cool. Oh no! I spoke too soon. Let me see if I can fix this. We've been trying out some fancy ways around. Nope, I'm not getting any of that data up. Okay, Enceladus is another object. Okay, how about Earth or Uranus? I will do you a twofer, Sam, since I didn't get your other objects. We'll start with Uranus, then we'll head to Earth. We can do kind of a blue planet theme. We can squeeze in a Neptune too, just for fun. So, quick, blue planet, rapid succession. We can start with a very distinctive blue planet that is Uranus. Uranus has that kind of robin's egg color with the yellow polar region. You've got dark and light clouds, both visible here. Dark clouds towards the pole, light clouds on the side. The pole is, of course, tilted towards the sun, one of Uranus's strangest features, and rings that would go around its side. Now, the rings are less visible than Saturn. Saturn for sure has the most visible rings. But Jupiter, Uranus, and Neptune have rings as well we've actually been able to take photos of. Now, heading out to Neptune, just to give us a little bit of a color contrast, that robin's egg blue for Uranus and the dark, deep, rich, almost purpley blue for Neptune. I guess that makes sense. Uranus is a god of, I think, time, Oranos, and then Neptune is a god of ocean. So I can see assigning the nice deep, rich blue color to the ocean god, or rather the ocean god to the deep, rich blue planet, because we found the planet within modern astronomy not too long ago. Unlike our classically known planets, which have been known for a very long time. Okay, and then Earth, I promised, for our final blue planet. Comparatively to Uranus and Neptune, Earth is sort of a washed out, not that rich blue. That's a little sad because we were so proud of calling ourselves a blue planet. From the nighttime side, it's pretty much dark. You can see our oceans here. They're pretty, they're blue. The blurring towards the edge is caused by our invisible atmosphere, which we can see in what's called atmospheric limning when you get very close to the edge of planet Earth. Now, you can also see our beautiful white clouds. We do have dark clouds, at least as viewed from below. I don't think we have too many dark clouds viewed from above like you do on Uranus and Neptune. That would be unusual for us to spot. We do have some dark features, like we can see that kind of yellowy haze appearing over on the west coast. That's smoke originating on the surface of Earth. So hopefully there's nothing burning on Uranus or Neptune. Wildfires are no fun. You can see our changing weather patterns though, and this actually does reflect weather that we are seeing yesterday. Really cool thing about OpenSpace is bringing in new information all the time as more data becomes available, but one planet we take a lot of photos of is planet Earth. We are always getting new shots of planet Earth. So pretty much every day you can see a new image taken the day before. You can even take it up to the second, getting the most recently taken shots of Earth. But when you do that, things start to get a little weird. Why is that? Well, when you're only using the freshest, most recent shots of planet Earth, sometimes they haven't finished taking photos of the whole planet yet, and that means that Earth just turns into an invisible bluish ball past a certain spot. We choose to use photos from the day before, primarily so we can see the entirety of planet Earth. Looking around, it is a pretty wonderful and beautiful planet, and unlike our other planets, we can actually zoom in and see some pretty exquisite detail here on planet Earth. We can do that on the moon, we can do it on Mars too, but on Earth we can go to a whole new level because of wonderful people with satellites flying around planet Earth, taking shots and sending them out to us. So let's check out, we spent all of our time in San Francisco. Let's go visit our friends across the bay over in Oakland. Now, as we're zooming in, you can start to see there's Alameda. Hi, Alameda. That's not Oakland proper. As we get a little closer, you can start to see lines, must be shipping areas. Down here, the harbor, super cool. If you know your friend's address, you can go creep on them from above and take some really cool visuals of the area around us. Now, in Google Maps or something, they have procedurally generated versions of houses. You can see really cool stuff like that. Here's some shipping boats out in the bay. They don't have that here. We have real photos, not trying to add in a whole bunch of extra kind of computer-generated information. So these are all photos put on the surface of planet Earth to give us a wonderfully detailed view of our city from above. Now, looking around here, we can see some topography if I level us out, but this is, again, data-based. So it shows us the curvature of the land around us. And really the only thing you would be missing are super tall buildings, because most houses are not going to be tall enough to register on this kind of a view. But we can see that wonderful terrain, the hilly areas that surround the Bay Area, and give us a really cool understanding of our spot on planet Earth. So this is a great way, if like me, you've been stuck at home for a while, and you decide, boy, I'd like to go sightseeing. I'd like to go visit my family. I'd like to go see cool places all over. Maybe you want to do the touristy thing and go visit Alcatraz. This is all stuff you can do from your home, from your computer. Give yourself a little bit of time and practice your piloting before you try and take your family on any cool tours. I've been doing this for a little while, so I make it look easy, of course. But you can go visit cities all across the world. You can see amazing, wonderful, and beautiful things from your own living room, from your own computer. It is a really cool way to defeat that feeling of stir crazy and to get a chance to see our beautiful planet for what it is. Okay, backing up from planet Earth, let's see if there's another cool spot. Comparatively, actually, I will take us over to Mars, but if there's someplace else you would rather see, please let me know. Taking us out to Mars, let's see what we can spot. Now, we saw on the surface of Earth down to like car-sized resolution. Most of Mars, we don't have that level of resolution. It's just a simple fact of Mars being another planet. We don't have a fleet of orbiting spacecraft taking high-resolution photos. We do have a couple. They're working very hard, but just not to the same level that we've imaged Earth. Now, looking around here, we can see some craters. We can see some lighter areas, darker areas. We can even see, I think, the corner of Valles Marineris. But when you pick a spot that you think looks cool on Mars, you could really just dive in and see how high the resolution gets. You can pull in extra detailed information called the CTX layer, and that'll give you super high resolution shots of smaller regions. And using that, we actually, with Dr. Lee, were able to go and visit the sand dunes on the side of one of the regions where they think they might be landing astronauts. That, to me, is just the coolest thing ever, to be able to see such an amazing special spot on the surface of another planet in much the same way we can visit spots here on Earth. Okay, so I'm going to let some of this data tile in, but it looks like we had a couple other suggestions pop up. Anyone else got an idea? The sun. Okay, so thinking about this, from Earth to the sun takes us about 8.5 minutes at the speed of light. Mars, again, travels a little closer and a little farther from the sun. Over the course of one Martian year, it's around 2 Earth years. So it can be a bit farther away or a bit closer depending on where it is in its orbit. But in general, Mars is about twice as far away from the sun as Earth is. So I'm going to guess that 16 or 8 times 2 is 16. With an additional half, we'd be at 17. So I'm going to guess a little under 17 light minutes for light to reach the sun from Mars, or more properly, Mars from the sun. But as my boss a little while ago pointed out in his very special way, when we see a photon coming to us from the sun, it's not actually a 8.5, or if you're on Mars, 16.5 minute old photon. It's actually millions of years old. Because by the time we see light exiting the surface of the sun, we actually see it being generated deep inside the sun. Deep inside the sun, very close to the core where fusion is occurring. And then from the inside layer of the sun to the outside, it bounces around, bumping into stuff, traveling this direction, that direction in a random path. It doesn't just travel straight out. And because it keeps bouncing around for all this time, we could have a 10 million year gap between when a photon, an individual piece of light, is born, created, and the time it actually hits your eyeball. That is a long amount of time. Ooh, Gabriel wants to know if we can see any comets. Well, I will tell you, Gabriel, right now, we just passed a moment where a comet was very visible. It was a nice comet, probably the best one I've seen in my astronomical career. But if you want to know about any upcoming comets or opportunities to see them, I would actually suggest tuning into our broadcast tomorrow at 1:30. Bing Kwok is behind the scenes right now, but he is a astronomer par excellence and can tell us about anything that might be upcoming in terms of comets or super cool things called meteor showers. And if you're a 4-year-old and want to see some really cool stuff, a meteor shower is a great thing to see. Okay, so we had a suggestion from Richard to see Mercury. Now, Mercury is kind of the most challenging, I would say, of the 5 classically known planets. And why is that? Well, Mercury is not big. It is the smallest of our major planets. It always hangs out close to the sun, at least relatively close. And it's very hard to see things that are close to the sun. Imagine holding a small candle next to a searchlight. The searchlight's so bright, it washes out the little candle. And if it was not even giving off its own light, just reflecting light like planets do, well, then things get even more challenging. So if you want to spot Mercury with your own eyeballs, you usually have to look very close to when the sun is rising in the morning or when the sun is setting in the evening and look for a bright-ish point of light right in that same direction as the sun. Certain times of year are better than others. There's a lot of people who blame Mercury, poor sweet Mercury, for all the things that go wrong in their life just because it happens to be moving backwards with respect to the stars. They call it retrograde. Mercury never did anything to anybody. It's just a cool little planet with some beautiful crater features on the surface. Ooh, Shireen, I will take you to Venus in just a second. I have one last thing I want to check out on Mercury. This is something I think is fascinating. The more you look at craters, the more interesting they become. At first, they just look like dents on a planet's surface. But you can actually start to tell a lot about the force of the impact based on the shape and the size. You can learn about the age of them based on which ones are on top of others. Let's try it out with this set right here. I see a little crater and a big crater right there. Which do you think was there first, the little crater or the big crater? Again, little crater, big crater. If you spend enough time looking at these, the answer becomes obvious. Might not be obvious at first, but the little crater is sitting on top of the big crater. So the big crater had to be there already when the little crater happened. Similarly, you can look at this even bigger crater out here and say, well, this crater had to be there when this crater happened, and then this one happened on top. But then look over here, we've got another crater that's overlapping that one. Maybe they happened at the same time, but I think this one looks a little bit more prominent. So I would say A and then B, and then maybe C and D. And using that very simple idea, which crater appears on top of which one, you can start to date huge regions of Mercury and the moon, understanding with great detail which objects happened first, second, third, fourth. It is a really cool idea to be able to piece together the history of an object like this. Now, going from super cratered Mercury, we are going to fly to the next door planet, which is Venus. When we get to Venus, big exciting news about Venus, we found compounds in its atmosphere that sometimes are made by life here on Earth. On Venus, they're probably not made by life. They're probably made by geology we don't understand, but that's still pretty exciting. There's a whole new kind of evidence we can begin using to learn about the surface and changes that occur within Venus. Now, looking at Venus, we can see pretty much those yellowy clouds. That's why Venus is so incredibly bright in the sky, as we are seeing light bounce off those clouds. But if we really want to see the surface of Venus, we actually have to fade that atmosphere away, and then we get to see a place that looks completely different than Mercury, completely different than Earth, and fundamentally very different than Mars. We can see a place that has very few craters. And you spend time looking around, you will definitely find some, but not too many. That ripply surface tells us about volcanic changes over time, but there might actually still be some volcanic activity occurring on Venus. Maybe that could be the source of our complex chemistry. Ooh, want to see the North Pole of Jupiter or a close-up of Saturn's rings? We can probably manage that. Okay, North Pole of Jupiter, here we come. Let's fly us out to Jupiter. Now, when we talk about a North Pole, we often assume planets are all rotating the same direction as planet Earth, which is not necessarily the case. Venus's North Pole is the subject of some controversy. We're talking about on Venus, we want to see the North Pole. Some people say it would be the opposite orientation of the rest of the North Poles in our solar system. For Jupiter, though, there's a great and easy hack to tell which part you are looking at, which is using the software, you can turn off nighttime on Jupiter, find our great red spot, and then that's on the southern side, so that would be our South Pole, and up here would be our North Pole. In our software, you can see the North Pole is a little stitched together, not quite as perfect a circle as this, actually, but you still get to see those changing bands as you get closer and closer to that polar region. Let's check out our rings of Saturn really fast. Just one planet out. I could totally show you the rings of Jupiter, but they're very hard to see. Saturn's rings are so much more obvious, so much more evident. And when we get to them, you will notice them in a telescope or binoculars from Earth. Saturn looks kind of oblong, like an oval. And you get right there. Ooh, that's beautiful. Those razor-thin rings, some people say are about 20 meters thick. Other people estimate up to 1 kilometer at their thickest, but they are very thin compared to their distance across. Okay, we have a question from SB to go see Pluto. I think that makes a great way to finish up our show today. We are coming a little short on time, but in our last few moments, I'm going to fly us out to Pluto. As we are heading out to Pluto, you will begin to see it getting lighter and brighter right in the middle of our view, alongside its major moon, Charon. As we get closer to Pluto, you can start to see a distinctive color, kind of lightish, grayish, maybe hints of pinkish. This is a cool looking place. Now on Pluto, we can actually put back into use what we learned on Mercury and Venus. The more craters you see, the older a surface is. Venus has very few craters. We think of Venus as a younger surface. Well, let me show you this amazing region on Pluto. Check this out. Now, looking around here, I'm going to challenge you, SB, you and your 5-year-old, see how many craters you can count on this part of Pluto. It's an easy counting problem. I count 0. This is a very smooth region. We think the reason this is so smooth is, like Venus, it's new. And even Venus has a few craters, so this must be very new, probably brand new. This area, we suspect, is a nitrogen glacier. We are breathing nitrogen right now here on planet Earth. It's what most of our air is made of. But on Pluto, it is so cold. How cold is it? It is so cold that the nitrogen forms a toothpaste-like sludge on the surface. Looking around Pluto, you can see these amazing cracks and rifts. Like Saturn's major moon, Titan, you can actually tell that the surface of Pluto, what looks like rock, is ice. It's so cold out here that the ice has formed this thick crust, and we see boulders, not of rock, but of ice on its surface. Pluto is a beautiful place, and if you want to find out more about Pluto, download OpenSpace, fly around, pick out some cool features, take photos of them, send them to us. We would love to see what you find on the surface of Pluto. And if you are a fan of this, you can watch our presentation later, as well as previous weeks. You can find all the promises I've broken to cool people like Sam. And you can see me rapidly and frequently contradicting myself on what my actual favorite moon in the solar system is. So we encourage you to check them out. Absolutely, on OpenSpace on YouTube and on the Morrison Planetarium Facebook. You can watch all of our previous virtual tours of outer space, as well as our other programs. But if you are enjoying this, we would really appreciate it if you can find the time to log in and take our survey. Again, we will send you a sticker because we think it is such a cool and important thing to do. Fill out that survey. First 30 respondents get that NASA meatball sticker. Let us know what you think of the program. Let us know what you think of the software. And please keep tuning in. This is a very fun program for us to give, and it's one we intend to keep doing until we are able to reopen our planetarium at the California Academy of Sciences. Hopefully that's in not too long, but at the same time, I would be kind of sad because I've really grown to enjoy broadcasting out on these Wednesday afternoons. So with that, I would like to thank all of you for joining us here for our virtual tour of outer space. You can see I fast-forwarded time a little bit. Now we got a big bite taken out of planet Earth. So we'll look at Australia. Australia is a cool place. Again, on behalf of myself, Morrison Planetarium, the American Museum of Natural History, and our friends at OpenSpace, thank you for tuning in for our program today. If you have questions, drop them in the comments. We will do our best to circle back and answer any questions that pop up after the show. And tune in, again, to watch all of these previous broadcasts. We adore all of you for tuning in. Thank you for joining us. Have a wonderful rest of your day. Stay happy, stay healthy. We'll see you soon.